Matter is found in three states, namely solid, liquid, and gases. We will study each state and its properties in this chapter. Solid. In a solid, the atoms are closely packed together. Solids have a definite shape. Solids have a fixed volume. Solids are rigid. Solids cannot be compressed. Let us understand each of these properties one by one. Over here, I have taken the example of a wood. Now, wood is a solid. So, how does it look like from the interior? Well, in a solid, the molecules are very tightly packed together. The force of attraction between the molecules is very strong. There are almost no spaces between the molecules of a solid. The next property is regarding the volume of a solid. So first let us understand what is the meaning of volume. So volume is basically the space that an object occupies. Now solids have a definite, that is a fixed volume. The reason why solids have a fixed volume is because the molecules are very tightly packed together, and this makes the solid to have a fixed volume. The next property that the solid possesses is rigidity. Well, what is the meaning of being rigid? So it refers to the property by which solids retain their shape when external force is applied on it. Let us try to understand the meaning of rigidity with the help of an example. So, what did we learn about it? We learned that substances are said to be rigid when they do not change their shape when external force is applied. Let us understand with the help of an example. If we have a stone and from all the sides we apply external force, what will happen? Will the shape change? No, the shape of the stone does not change. Hence, we can say that the stone is rigid in nature. However, on applying more force, the stone may break, but it is extremely hard to change the shape. Hence, we can say that the stone is rigid. That means the shape of solid does not change on external forces applied. However, the solid may break on appliance of further force. The next property is compressibility. So, compressibility is the measure of how much a given volume of matter decreases when placed under pressure. Solids cannot be compressed. Let us understand with the help of an example. So, solids are incompressible. That means when we apply pressure from all the sides on the solid, its volume will remain the same. The volume remains unchanged. Once again, let us take the example of a stone. When we apply pressure on the stone from all the sides, does the volume change? No, the volume remains the same. Hence, we can understand that in case of solids, when we apply pressure, the volume remains constant, the volume does not change. Hence, solids are incompressible in nature. Now, the next state of matter that we have to study is liquids. Now, liquid molecules have spaces between them, and the force of attraction between the molecules is less as compared to the solid. Over here, we can see in the image that the molecules of liquid have spaces between them. So, the first property of liquids is that liquids do not have their own shape. They easily take up the shape of the container in which they are kept. However, they do have a fixed volume. Liquids can be measured using the volume. So, one example could be when in the evening you see that the milkman arrives in your house, he measures the milk and give it to you, isn't it? So what is he measuring? He is basically measuring the volume of the milk. Hence we can say that the liquids can be measured using their volume because liquids have a fixed volume. Next is fluidity. So, liquids can flow, isn't it? What will happen if you just drop a glass of water on the floor? The liquid will spill all over your house, isn't it? That means the water has the capacity to flow. So why does it happen that the water in the river flows? The reason for it is because in case of liquids, the molecules are far away from each other, because of which there are spaces and the molecules can move slightly from one place to another. That makes the liquid fluid. That means your liquids are allowed to flow because of the weak intermolecular forces and because of the spaces between the molecules. Next property is that liquids flow from a higher to lower level. Have you ever seen a waterfall? How does the water really fall? The water falls from a higher level to a lower level. While you're pouring tea or coffee in your mug, the mug is kept at a lower level. However, the teapot is kept at a higher level. Isn't it? So what do we understand? That liquids flow from a higher to lower level. That is certainly one of the reasons why the water tanks are placed on top of the roof, because the water flows from higher to the lower level. Now, the next property of liquids is that the melting point of liquid is below room temperature. However, the boiling point of the liquid is above the room temperature. Let us understand with the help of an example. The boiling point of water is 100 degrees Celsius. Now 100 degrees Celsius is quite higher than the normal room temperature. So what did we conclude? We concluded that the melting point of the liquids is below room temperature. However, the boiling point is above the room temperature. Today we will be studying about gases. Let us look at the properties of gases one by one. Before that, let us first look at how the molecules in a gas are arranged. As you can see in the figure, the molecules of gas are extremely far away from each other. The molecules are so far away from each other that there is almost no force of attraction between the molecules. So due to the space, there is negligible force of attraction between the molecules. The next property that we need to see is kinetic energy in the gas. But before that, let us just try to recall what kinetic energy is all about. So, the energy that an object possesses due to its motion is called as kinetic energy. So, any moving body possesses kinetic energy. As we can see here, the molecules of a gas keep moving at very high speed, and because of which they acquire large kinetic energy. So, in the gas, the molecules have high kinetic energy. Why? Because they constantly keep moving. What do we see in this figure? Well, we see that the molecules are separated by very large space, and as a result, the molecules have no force of attraction between them. So, the gas molecules have negligible force of attraction between them. As compared to the solids and liquids, gases are highly compressible. That means when you apply large pressure on the gas, you can easily compress it. What would be one example of it? Well, in our daily lives, in our homes, we use LPG cylinder. You all have seen it, I'm sure. Now, that LPG is also a form of compressed gas. Look at the slide. What do we see? We see that molecules are moving in all directions, and also they are exerting pressure on the walls. Can you see the molecules? They are moving in all directions. At the same time, they are hitting the walls of the container. So basically, the molecules exert pressure on the walls of the container. Now, they exert equal pressure on all the walls of the container. So it is important to remember that the pressure is equal and uniform on all the sides of the container. Now look at this. What do we see? The molecules of a gas are spreading out. That means the molecules occupy the complete space that is available in the container. Also, the molecules move and they collide with each other. They undergo collision. That means at times the molecules also hit each other. So that is random collision. Now that we have studied about all the states of matter, let us now study the differences between them. So, in this new video, we will be studying the differences in properties between the solids, liquids, and gases. The first property or the first base of distinction between the three is mass, shape, and volume. So let us see the difference in solids, liquids, and gases depending upon their mass, shape, and volume. So in the solids, since the molecules are tightly packed together, it has a definite mass, definite shape, and also a fixed volume. In the liquids, the liquid has a definite mass. However, it does not have a definite shape. It acquires the shape of the container in which you keep them. But one thing that is to be noted over here is the volume. Liquids may not have a fixed shape, but they do have a definite volume. Now let us see about gases. Well, gases also have definite mass. How do we know this, that they have a definite mass? Let us try to think of an example over here. Suppose if you have two balloons, you blow air in one balloon and you don't blow air in the other one. Now you measure both of them. On measuring, you will find that the balloon in which you had blown air is heavier as compared to the other one. Why is it? Because it has its own weight. That means it occupies some mass. So gases have a definite mass. However, it does not have any shape and it does not have a proper volume. It has no fixed volume. So just like liquids, gases too acquire the shape of the container. The next property of distinction between the three states of matter is fluidity. So we already know that solids cannot flow, reason being the tightly packed molecules, and liquids can flow. Liquids can easily flow. However, whether a liquid will flow fast or no depends upon its viscosity. The next is gases. So yes, gases can also flow. Gases can flow in every direction. So one example for this would be when you light your incense sticks. What do you see? The smell spreads in the entire room. Also, if you have seen smoke also spreads around, isn't it? So all of these were examples showing that gases can flow. That means gases can spread, isn't it? The next base of distinction is the rigidity. Well, solids are extremely rigid, while liquids are not rigid and gases are also not rigid. So that means when you apply force, external force, the solids will hold their shape. They will not change their shape. However, liquids and gases do not have a proper shape, so obviously they are not rigid. The next property of distinction between the three is the compressibility. So we already have studied all these properties before, but let us do one comparison now. Solids, you already know that no matter how much pressure you apply, you cannot change the volume. That means solids cannot be compressed. Same as with the liquids. Liquids are also very negligible to compressibility. So that means even if you apply pressure, it is very hard to change the volume of the liquids. However, the gases are compressible. So you can definitely apply pressure and compress the gas. Now, The basis of distinction or the properties using which we will distinguish between solids, liquids, and gases are the packing of the molecules and the intermolecular force of attraction. So over here we have three figures. The first figure shows the arrangement of solid, the second one of liquids, and the third one shows the molecular arrangement of gases. What do we see? The first figure shows that the molecules in a solid are very tightly packed together. They are held so tightly because they have high force of attraction. The molecules are held together with extremely high intermolecular forces. If we look at liquid, the liquids have slight spaces between them. There are small spaces between the molecules of the liquid. And also, if you compare it to solids, the intermolecular force of attraction is less. But if you compare it to solids, the liquids will have a higher intermolecular force of attraction. Now, looking at the molecular arrangement of gases, we can see that the molecules are extremely far away from each other. So obviously, the force of attraction is almost negligible, almost not there in case of gases. The next property for distinguishing between the three states is the kinetic energy. Now, solids have the least kinetic energy. What could be the reason behind it? We already know that kinetic energy is the energy possessed by the object because of its movement, because of its motion. Now, since the molecules of solid are so closely packed together, they cannot move. That is why they have least kinetic energy. Now, molecules of the liquid have slight spaces between them that allows them to flow, and because of which they have large kinetic energy. And when it comes to gases, gases have the highest kinetic energy among the three. The reason being the large spaces and the negligibility of the intermolecular forces.